Okay, so a team of scientists, including some heavy hitters like Harvard's Avi Loeb, just dropped a new paper with a title that is frankly impossible to ignore. They're taking a hard look at the newest visitor to our solar system, an object named 3I/Atlas, and they're asking a question that sounds like it was ripped from a movie script.
And they are not beating around the bush. They're asking straight up, could this visitor be more than just a random rock? Could it actually be an extraterrestrial probe? Now, I know what you're thinking. That sounds completely wild, but their entire analysis is based on some very real and very, very strange data.
So let's meet our object of interest. It's called 3I/Atlas, and it was first spotted by our telescopes back in July of 2025. Now, what makes this thing so special? Well, it's only the third object we have ever seen that has come into our solar system from the vast, dark space between the stars. So, what do we actually know about this mysterious traveler from another star system? Let's break down what the astronomers saw right off the bat. Almost immediately, it became clear to astronomers that this wasn't just another Oumuamua or Borisov, our first two interstellar guests. No, this visitor is different. It's leaving behind a trail of really strange clues, a whole set of anomalies that just don't quite add up. And here's the core of the whole mystery. 3I/Atlas isn't acting like a comet, but it's also not really acting like an asteroid. It seems to be something else entirely. And it's this weird, unpredictable behavior that triggered this whole investigation. And this table really lays out the case file. First, its path through our solar system. It's almost perfectly aligned with the flat plane of the planets, but it's going backwards, against the flow of traffic. The odds of that happening naturally are just 0.2%. Then there's its size. It's enormous for an asteroid, but it's not giving off any gas or dust like a comet should. And get this, its trajectory takes it on a grand tour, with incredibly close flybys of Venus, Mars, and Jupiter. And the cherry on top? Right when it gets closest to the sun, it will be perfectly hidden from our telescopes. Convenient, huh?
Let's focus on that comet problem for a second, because it's a big one. An object this huge, we're talking about 20 kilometers wide, should be outgassing like crazy as it gets baked by the sun. It should have a big, visible tail. But we see nothing, just a huge, dark, silent object on a suspiciously precise path.
Okay, now this number? This is where things get really wild. The researchers actually calculated the odds of a random interstellar object having a trajectory that just happens to line up for close flybys of Venus, Mars, and Jupiter, all in one pass. The probability? Less than 0.005%. I mean, that's not just rare, that's statistically absurd. It's like throwing a dart from another solar system and hitting 3 different moving bullseyes. And the way it got here seems almost planned. It came from the direction of the galactic center, which is one of the brightest, most visually crowded parts of the sky, a perfect place to hide. In fact, by the time we actually spotted it, it was already too late to even think about launching a mission to go meet it. And that super rare flat orbit? Well, it just so happens to be the perfect angle you'd want if your goal was to measure the orbits and masses of our planets on your way in. So, when all the natural explanations start to feel like a stretch, what's left? This is where the paper's authors decided to explore a really unconventional and absolutely fascinating hypothesis. Now, this is a really important point. The scientists are very clear. They are not saying it's aliens. They frame this whole thing as a thought experiment. They actually say it's an idea that's fun to pursue, whether it's likely to be true or not. What they're really doing is asking, okay, let's just pretend for a second this was a probe. What would its mission be? It's this kind of creative thinking that helps us build a playbook for analyzing future weird objects. And if it is a probe, why would it be so sneaky? The paper brings up a concept called the dark forest theory. It's a pretty chilling potential answer to the famous question, where is everybody? The theory suggests the universe is like a huge dark forest filled with silent hunters. Every civilization stays quiet because making a sound, revealing your location, is a fatal mistake. So if you're gonna go out and explore, you do it very, very quietly. Which leads us to the most compelling part of this whole thought experiment. If this object is on a mission right here in our solar system, what would that mission strategy be? So let's put on our mission planner hats for a moment. If this thing is an intelligently guided probe, what's the game plan? Well,
its trajectory might just give us the whole playbook. The key to the whole theoretical mission is a move called the reverse Solar Oberth Manoeuvre. It sounds really complicated, but the physics is pretty straightforward. If you want to slam on the brakes in space in the most fuel-efficient way possible, you do it when you're moving at your absolute maximum speed. For a spacecraft, that's when it's making its closest, fastest pass by the sun. It's the perfect way to arrive in a new solar system and decide to stick around. And wouldn't you know it, the trajectory of 3i/Atlas makes this sneaky braking strategy totally possible. Let's run down the checklist. Step 1. Approach from a cosmic blind spot. Check. Step 2. Time your closest approach to the sun for the exact moment you're hidden from Earth's view. Check. Step 3. While you're concealed, fire a big engine to hit the brakes and drop into a stable orbit around our sun, and we would never even see it happen. The paper even explores other mission ideas. For example, from its path, it could act as a mothership, deploying smaller probes to check out Venus, Mars, and Jupiter, using very little energy. We're talking a level of thrust similar to what an ICBM uses. Or maybe it's not a rocket at all. The paper notes its physical properties are actually consistent with it being a giant solar sail, one with a design very similar to ones we've developed here on Earth. So, after all this data and all this incredible speculation, where does that leave us? What's the final verdict on 3i/Atlas, at least for now?
And this is where the scientists bring us all back down to Earth. They conclude that despite all these fascinating anomalies, by far the most likely explanation is that 3i/Atlas is a totally natural object, probably just a weird comet. And this is what great science looks like. You explore every wild possibility, but you always land on the most probable answer until the evidence forces you to do otherwise. But, and this is the best part, this isn't just talk. The alien probe hypothesis makes a real, testable prediction. Mark your calendars. On October 29th, 2025, it's going to disappear behind the sun. If it performs that braking maneuver, the paper calculates it could arrive at Earth sometime between late November and early December 2025. Or maybe it settles into a nearby orbit in 2026. And if nothing happens, well, then the hypothesis is almost certainly wrong. Ultimately, no matter what 3i/Atlas turns out to be, this paper is incredibly valuable. It's a pedagogical exercise, a teaching moment that creates a framework, a kind of anomaly checklist for us to use when analyzing future interstellar visitors. And with new observatories about to come online, we're going to be seeing a lot more of them very soon. So, is 3i/Atlas just a harmless, if slightly quirky comet, or is it a carefully calculated opening move on a cosmic chessboard? For now, it remains one of the most fascinating puzzles out there. But unlike most cosmic mysteries, this is one where we're actually about to get an answer. The verdict arrives in 2025.